I think we have been using this word phase difference quite a lot. Let's now try to understand the meaning of that. Let's now try and understand the meaning of phase of vibration and phase difference. Now, here I have a particle, my basketball. If I set it into vibration, I want you to watch some of the terms I'm using. If this is the equilibrium position, it vibrates to an upper extreme. You can see that is the phase of vibration now. Back to the equilibrium, to the lower extreme, back to the equilibrium. That's one vibration. You see, each phase of vibration, the particle is at different positions. All right, so what is the meaning of phase of vibration? Let's consider several particles oscillating between two extremes. Now here I have particles 1 and 2. Particles 1 and 2 are at the equilibrium position and they are both moving up. Now let me see if I can illustrate that here. If I have particle 1 and particle 2, they are both moving up together, back to the equilibrium, down, back to the equilibrium. We can say they are both in the same phase of vibration. So particles 1 and 2 are in the same phase of vibration because they will be always at the same positions. You see, they are in step. They are both in the same phase. There is no phase difference between them. When particle 1 is at the upper extreme, particle 2 also is the upper extreme. Particle 1 is in the equilibrium position, particle 2 is also there. There is no phase difference. While particle 3, watch the motion of particles 3 and 4. While particle 3 is beginning to move up, particle 4 has completed going up and coming back to the equilibrium position. It is now beginning to move down. All right? I want you to understand that the phase of vibration is associated with the position. Look at this. Equilibrium position, upper extreme, equilibrium, lower extreme, back to the equilibrium. Now, remember, the time taken to vibrate completely once is called a period. Now look at these two particles now. Now, particle 2 has gone to the upper extreme, back to the equilibrium position, and now it is beginning to move down. And particle 1 is beginning to move up. Now that means this particle in my right hand. Now when I say my right hand, it will look like the left hand to you in the picture. You see, this particle that is beginning to move down is half a period ahead of the particle that is moving up. Now what does that mean? Remember, the time taken to go up, back and down and back is one period. So this particle has gone up and come back. That means it has already covered half a period. So we can say particle 4 is half a period ahead of particle 3. When particle 3 begins to move up, particle 4 has completed half the vibration and begins to move down. I hope you got a picture of what that is. Particle 3 has to go to the upper extreme and back to catch up with particle 4. So by the time 4 would have gone down and back, they are always moving in opposite directions. Now what is the phase difference between particles 3 and 4? You can actually, we define phase and phase difference using the angle. Now I want you to understand the angle concept. Alright, give me a second, I will review that with you. The angle as the particle begins to move up. Remember, when it is all the way up, the angle is pi by 2 and the period is t by 4. When the particle is back at the equilibrium position, the angle is pi and the period, the time, is half of the period. When the particle goes all the way down, the angle is 3 pi by 2, you see? And what is the time in terms of the period? It is 3t over 2. And finally, when the particle is back at the equilibrium position, the angle is 2 pi and it has completed one period. Alright, I think I made more of a mess here than explaining, is that right? Now let me try it once again. Now if the particle is at the equilibrium, we say the angle is 0, the period t, because it hasn't started, is 0. In a quarter of a period, it reaches the upper extreme. Then the phase angle is pi by 2. In half of the period, when the period is half of the period, the phase angle becomes pi. You see that? In 3 half, when the particle goes down to the lower extreme, it has now completed 3/4 of a vibration. So the phase is 3t over 4, which is the same as 3 pi by 2. And when it is back to the equilibrium position, one full period is the same as the phase angle of 2 pi. So the phase difference between particles 3 and 4 is pi, because particle 4 is half a period ahead of particle 3. Alright, can you now tell me, looking at this, what is the phase difference between particles 5 and 6? 6 has just completed quarter of a vibration. The phase difference is a quarter of a period, which is the same as pi by 2, a phase angle of pi by 2. Alright, so tell me, what is the phase difference between particles 7 and 8? Particle 8 has completed what part of the vibration? It has completed 3/4 of the vibration. It is now left only the last quarter. That means its phase is 3t by 4. Is that right? 3t by 4, which is the same as 3 pi by 2. The phase difference between the two is 3 pi by 2 phase angle. In terms of the period, it will be 3t by 4. Alright, now here I have how many particles? 5 particles of a medium. Consider 5 particles of a medium oscillating with a phase difference of t by 4. What does that mean? What is the meaning that the phase difference is t by 4? It means when the first particle completes quarter of a vibration, the energy will just reach the second particle, it will begin. That is the meaning there. And when the energy reaches the third particle, the second particle would have completed quarter of a vibration. The first particle would have completed half a vibration. Alright, let's set it up like this. If the phase difference between successive particles is t by 4, remember that t by 4 means quarter of a period. As the first particle completes 1/4 of a vibration. 1/4 of a vibration means from equilibrium it will go all the way to the upper extreme. There you are. So particle 1 has now completed 1/4 of a vibration. It is now at the upper extreme. The energy will now just reach the second particle. Now look at the profile of these two particles. They are not in the same positions anymore. After another quarter of a vibration, after another quarter means after half a period. You see, this is 1/4, after another quarter, the energy is going to reach this particle. So tell me, where is the first particle now? The first particle has completed one vibration. Completed half a vibration. You see that? The second particle has done a quarter of a vibration, and the energy just reaches the third particle. And look at the profile of the three particles now. Alright, what happens after another quarter of a vibration? Now how many quarters? It is now 3/4 of a vibration. So the first particle has now completed 3/4 of a vibration. Where is it now? It is at the lower extreme. Where is the second particle? It has completed half a vibration. It is at the equilibrium position. There you are. Now where is the third particle? It has completed quarter of a vibration there. And the energy reaches the fourth particle here. And look at the profile now. Isn't that beautiful how the wave profile takes shape? What is the situation after another quarter of a period? After another quarter, particle 1 has completed one vibration. That is one period. Alright? Particle 1 has completed one vibration. Where is particle 2? It has completed 3/4 of a vibration. It is down here. Where is particle 3? It has completed half a vibration back to the equilibrium position. Particle 4 has completed a quarter of a vibration, and the energy just reaches the fifth particle here. And look at the wave profile. And now, can you tell me, what is the state of vibrations of particles 1 and 5? Particle 1 has completed one vibration, is now ready to start the next vibration. And particle 5 has just received the energy, it is ready to start vibration. Is that right? Yes, that means particle 1 and particle 5 are going to be now in the same phase of vibration. Right? Particle 1 and particle 5 now begins to move up at the same time. That means they are in the same phase of vibration. There is no phase difference between these two particles. You can see the meaning of a progressive phase difference that creates the positions of the particles at the differences of the position that creates the wave profile. By the time particle 1 completes one vibration, look at the energy has reached the fifth particle. You see? Very important information. The distance advanced by the wave in a time of one period. You see? The time taken by the first particle to complete one vibration is one period. And what is the distance advanced by the energy during that time? Is the distance between particles 1 and 5. Now, this distance is called the wavelength of the wave. So tell me, what is the definition of wavelength? An important concept. Wavelength of the wave is the distance advanced by the wave in a time of one period. That is the definition of wavelength. Wavelength is represented by the Greek letter lambda. Lambda. Alright? So this length is the wavelength. Wavelength is represented by lambda. The distance between two nearest particles that are in the same phase of vibration is wavelength. Another definition, or the basic definition of wavelength is the distance advanced by the wave during a time of one period is wavelength. So, wavelength can also be defined as the distance between two nearest particles in the same phase of vibration. Alright, Now, that is the concept